All right. Now that we've gotten through the photoelectric effect, the Compton effect, the de Broglie wavelength, all of this is leading up to the models of the atom and what the atom actually looks like. So if you remember back then, in the late 1800s, early 1900s, they still didn't know what the atom looked like. But more and more they were trying to figure it out. Okay? But we need to go back a bit before that. The word atom actually dates back to about 400 BC. Okay? It's a Greek word and it means indivisible. If only I could spell it visible. Here we go. Indivisible. Okay? And it was first coined by a philosopher, a Greek philosopher. If we were in class, I would make you guess which one. You might not get it. It's Democritus. Okay? So Democritus suggested that you could take any substance and keep breaking it down, like cutting it in half, cutting it in half, cutting it in half, cutting it in half, into smaller and smaller pieces until you got to like that ultimate particle that could no longer be split into smaller particles. And he called that tiniest piece that is indivisible, he called that an atom, because it is right, an indivisible one. In Greek, the word atom is atomos, and it means indivisible. Okay, so Democritus imagined that everything, the chair, the desk, the tree, you and I, could be broken into tinier and tinier pieces until we'd eventually get to a point where the pieces that we had couldn't go any smaller. And those pieces he called atomos, the atom, because he saw them as being indivisible. He saw them as being the ultimate particle. Okay? Now, it was pure speculation. Obviously, in 400 BC, he didn't have a lot of fancy equipment to do any kind of experiments. That's why all those Greek guys were called philosophers. Even like before we started doing experiments, all the physicists were really philosophers because they were doing what's known as theoretical physics. They were thinking about it and speculating on what should be, but didn't really have a lot of way of proving it or testing it. Okay, so the word atomos then has been around forever. And people kind of understood its concept. And Democritus was right. We just today applied the word too soon. We applied it, we thought we got to the particle that was indivisible. But now, 100 years later, we know that what we call the atom is divisible. And so we called the wrong thing the atom. Okay? So the atom then, the word the atom from 400 BC, it's in people's subconscious, some maybe more than others, but the idea of it surfaces again in the 17th century. And we re-see it in the 17th century with Robert Boyle. And I'm pretty sure from chemistry you would have heard of Robert Boyle and Boyle's law. Boyle was studying gases. And what Boyle noticed was that as the pressure increased, the volume decreased. So as the pressure went up, the volume went down. And that made him think that the gases were made up of particles and that those particles were separated from each other. And as we increased the pressure, then we squished those particles together. And when we decreased the pressure, those particles were able to separate. And because of that, those particles, he imagined, were these atoms that Democritus was talking about. Okay, so the atom now comes back into play. So he says, okay, gases are made up of these tiny particles separated from each other. And then when we put pressure on them, they get closer together, so the volume decreases. When we release the pressure, they spread apart. Okay? So that was during somewhere in the midst of the 17th century. Towards the end of the 17th century, the next two that refer to the atom are Lavoisier and Prost. Okay? Now, these two guys were measuring the amount of elements that went into a reaction and the amount of product produced. Okay? So they were looking at the reactants and the products. And what they noticed was that the elements always reacted in certain proportions, like one oxygen always reacted with 2 hydrogen to give them water. Oops. Okay, so they noticed, and I know Mr. Jewett would have a fit the way I just wrote that, but I just wanted you to, okay, so they noticed that the elements always reacted in certain proportions, okay? And so then they suggested that a certain number of one atoms combines with a certain number of the others. So they went back to this idea of the smallest possible particles must react in proportions, in certain proportions, okay? So that was the end of the 17th century. So 1808 was John Dalton, and I know you've heard of him. John Dalton gave us what was called the modern atomic theory. Now, for them it was modern, right? Because everything else was earlier. When we talk about modern physics, it's usually the 1800s. So it's not really that modern anymore, but it was at one time. Dalton proposes the model that you would know as the billiard ball model. I say you would know because I think that's what they call it in chemistry. Okay? But Dalton's atomic theory, modern atomic theory, proposed several things. One was that pure substances, what we would call elements today, pure substances were made up of identical small particles. Which, of course, we call atoms. So what he's saying here is if you had a lump of gold and you broke it down into its smallest possible pieces, like Democritus was suggesting, he's saying those smallest possible pieces would all be identical if it was a pure substance. The second thing he said was that, so these pure substances today, we would know them as elements, right? So the second thing he said was then that different pure substances, or in other words, different elements, were made up of different atoms with different properties. So different elements were made up of different atoms with different properties. So if I had gold and I had aluminum, I could break them both down into their tiniest possible particles, these atoms. All the atoms in the gold would be identical to each other. All of the atoms in the aluminum would be identical to each other, but the atoms in the gold and the atoms in the aluminum would not be identical. They would be different, okay? So different elements. They're all composed of atoms, but different elements are made up of different atoms. And then the third thing he said was combined substances. Combined substances, which we of course would call compounds, are made up of combinations of different atoms. Combinations of different atoms. Different atoms in a set ratio. Okay, so my carbon dioxide is always going to be CO2. My water is always going to be H2O. Okay, a set ratio, and these set ratios are of simple